Jemmy, I think we can go ahead and start, and probably learners will join along the way.
Okay, let me get the slide up. Okay, I'm sharing my screen.
Yep, I can see it.
Okay, thanks. So today we are going to have a demo of Amazon CloudWatch for resource monitoring. When I was preparing for the demo, I realized that it's quite a difficult topic to prepare because CloudWatch itself doesn't mean much without the data, without the application for it to monitor. So we are going to have a demo application here. I will walk you through the demo application, and then we will go through some of the scenario that CloudWatch could help solving some of the observability and the monitoring issue that we have. First, about myself, my name is Chachapon Vitawatyanwet. It's a very long name. I'm from Thailand, and usually in Thailand, we all have a very long name like this. And to solve that problem, we also have nicknames since we were born. And mine is Jamie, so feel free to address me with that. We don't have a lot of learners today, so feel free to jump in the middle of the call, just if you have any question or you want to comment on anything. The middle mixture is my new hobby during the COVID time. Lately, I start to plant some herbs like basils and chilies. That is because like during the COVID time, I start to cook more, and it's kind of hard to find a nice ingredient for Thai food. So the right is a dish called tom yum. If you have been to Thailand, that's probably one of the most famous dish in Thailand. So I could use this herb that I plant into the dishes that I cook. Okay, so that is about me. But what about you? What is in it for you to look at this session? In this session, we assume that you have some of the basic knowledge of AWS service and some of the basic knowledge of CloudWatch already, but you haven't seen it in action. You haven't really used it a lot in real scenario. So instead of showing you like the terminology and concept in dry slides and I read them, I am going to go through the common operational scenarios and show that how CloudWatch could help in those scenarios. And where possible, I will give you like some of the advice that I learned from my previous work so that you can use this as a lesson learned from me, and you can apply this to your job when you work as a system administrator. Okay, the agenda today, we look at the demo of applications, and then we walk through 6 scenarios. The first one is the biggest questions is my service is still healthy? Right, and we will visit metrics and dashboards here. How the metrics work in CloudWatch, what are the core concepts, and how to create the dashboard. After we know that the application is healthy, we cannot keep watching the dashboard all days. So we need some kind of alarm. We need some kind of notification to take action automatically. And that's where the second question comes in. The third one is about when you know exactly that something is wrong, but you want to know that what went wrong inside of the application. Here, you need to dive a little bit deeper from the metrics into the logs. The logs is a kind of the text that you will see inside, and the application will split this log out. And then you can figure out that what went wrong inside the application from looking at these logs. The fourth questions come when you look at the logs. And in practice, you have a large amount of logs, and it's not easy to filter them. There is a feature called Log Insights, and we are going to I'm going to demo that today so that you know that if you see a lot of logs from multiple places, how do you aggregate them together? How do you filter and search through them? The next one is about the canary, and that is like when you have an application, and if something goes wrong, you want to be the first person to know that your application is broken. Right? You don't want the users to know, and then they call the contact customer centers, and then they start escalating to your boss, and then that is when you just get a notification that something is wrong from the alarm. So in order to do that, you need a kind of fake users, or they call it canaries, that keep running on your website and keep checking whether your website is working properly. And if something goes wrong, then the canary can trigger the alarm, and then you will know before the user, or almost the same as users, that something is wrong with your application. Last but not least, sometimes your application is working, but it is very slow, and you want to do some tracing to figure out that what caused the performance issue. And that is the last features of the trace. Trace is actually more on another service on X-ray side, but you can use CloudWatch to look at the trace also. So I'm going to do a very brief demo about this. Okay, those are the scenarios. Let's look at the demo application. We are going to use the application called Pet Adoptions. These are not real, so if you want to take some of them, no, that wouldn't work. We have some of the features inside of this. The main features is that you can search throughout the types of the animals. Here we have puppy, kitten, and bunny. So if I filter only kitten, I can also filter by colors, but I will just search for everything here. And then I will see only the image of the cat, okay? And that is the main features, the search and filtering. And then after that, I can have the features to adopt an animal. And I like Siberian Husky, so I'm going to adopt this Husky. Here, all of the payment information, everything is fake. It's just like an API that doesn't do anything, so I don't need to enter anything here. I will just click pay, and then it will say like, hey, the adoption is completed. And then I could go to see the adoption list on the top right here in the menu here, and then it will show off the adopted animal, and the Husky has already been adopted here. Okay, very straightforward application. It's basically like listing the animals, abilities to search through it, actually filter based on the types and the colors, and also the ability to update the data, in this case to adopt an animal. Okay, this one is from, this demo application is from a workshop called Observability Workshop. I provide a link in the slide. So if you want to deploy this and go through the workshop yourself, I totally recommend it. I'm using it here for the demo because we need to generate some load so that CloudWatch can show some metrics. And this application has this kind of load traffic generator. Looking behind the scene, it seems like a simple application, but there are a lot of components, moving components inside. This is quite a big architecture diagram, but let's break it down. We have the user, and it goes to the user request. When I enter the website, it goes through the ALB, or application load balancers. This ALB send the data into the Kubernetes nodes here. And this is where we have the front end. The front end is responsible for serving the email, the CSS file, the HTML file, and everything. But when they want to get more information, like trying to apply the search filter, it have to call another service. And here we have another service called Pet Search API, which also relying on the other two services here. Okay. And on the other hand, if I want to adopt a pet, I make a call to the front end, and the front end call another API, which is called pet adoption and status update. So basically what it does is it just update the pet to be adopted so that the same people cannot adopt the same pet twice. And it saves the data into the DynamoDB. In real life, probably you will not design an application like this, right? If you look into the details, you will also notice that this one uses Kubernetes, written in C#. This one is using ECS, written in Java. And then these two API also ECS, but written in Golang. And then the Lambda functions, also we have Lambda function that is written in Python and also in Node.js. So we have all kind of services here. So the idea for this one is trying to just simulate that in real life if you have microservices of the big application. you can face the situation like this and how CloudWatch could filter all this data. But for the application itself, this is a very contrived example. Okay. And one of the things that is left outside of this architecture is the thing called traffic generator. So while we are talking right now, there is a kind of a bot that keep accessing the website, and it performs some basic action like listing the pets or adopt some pets, on reset the data, so on and so forth. And these are this traffic generator is the one that send metrics that we will see later. Okay, so let's go to the first scenario. You have an application, is ready to be in production. You put in production, but now you have an additional question, is that you want to know whether your service is still working or not. And actually working is not the right word here. You have to say whether it's healthy or not, because there are many aspects of the application. For example, the application might be able to do what it's supposed to do, like performs normally, but it is very slow. Can you consider that healthy? And sometimes most of the website is still working, but some features is broken, it stopped working. For example, you have the website, but the adoption or the payment stopped working, right? Then could we consider that healthy? That's why the term here is not in the monitoring world, is they use the term healthy, like whether something is wrong or not. And you need to define the boundary that when it's healthy and when it's not healthy. Okay. When you want to answer this question, if you don't have any tool, you can just say, hey, I'm going to just manually test it. I will just go in, log in into the website as a user and perform some of the actions. But the problem with that is you need to be a user inside of the actual system. And if the system is related to payment, then I will have to make an actual payment in order to test that the feature work or not. And that is not very practical. And also, it takes a lot of time to do all of this. So the idea of this is we want to have the system to kind of monitor our application. And we can see at a glance whether our application is still healthy or not. So the first concept that we are going to visit to answer this question is about metrics and dashboard. There are many metrics, many types of the metrics, and you can categorize it in many ways, but one way is to divide it into infrastructure, application, and the business metrics. The infrastructure metrics is something that's very low level at the instance on the container itself. For example, the CPU utilization is one of them. On the application level, you can look at the latency or the volume of the request that is coming per second. The third is the business metrics. This is the high level. Let's say that you are the CEO of the pet adoption company. You want to know mostly like number of the pet adopted in the last month, or maybe the total revenue that you have generated from the payment data. So these are the three different types of metrics that you usually find common. Normally in AWS, the first type of metrics is usually built into the service itself. For example, the CPU utilization and the disk I/O is always emitted in the container and from the EC2 instance. So you just need to just grab that matrix. But for the applications and the business metrics, sometimes you need to create a custom metrics. And that means your application has to send the data whenever the action takes place. For example, if you want to know the number of the pet adopt, that means you have to record the number of the pet adopt in whenever the request for the payment is completed. And that has to be done also on the code. Okay. So let's start with the demo of the metrics then. Here I am on the landing page of CloudWatch. I look on the left-hand side and there are many features here. The first one we will look at is the metrics. Here I can look at all the metrics and then see, I will come to this place. Okay. I would like to point out to the part below. We have two sections. One is the custom namespace and another one is the AWS namespace. So as I told you before, usually the infrastructure metrics are emitted automatically in AWS services, and these metrics are usually under the AWS namespaces. Okay, if you look here, you will see that these are basically like the service that AWS provided. If you want to have a custom one, then you can look at this one, because the application that has been deployed, it has already had some of the custom metrics in itself. So you will see them in the custom namespace here. I'm going to look at one of them, and it's about the container. And then I can click from the namespace into the metrics, and then I could dive into the part called dimension. Here's the dimension. And then I go a little bit further into the metrics themselves. So here we can see that we have the metrics from different namespace, different cluster, and also from the different pod. If you're not aware of pod, you can think of that as a kind of a unit of the application. Yeah. And the metrics that I'm interested in is the CPU. So I'm going to filter here. And there are quite a few of them in the different pod. I could just take one of them. So I'm going to take, well, I would just take the first one. Yeah, CPU utilization. Right? And this, we show the metrics, the data in the graph format. Okay. Now moving on, I can switch the tab from the all metrics and go to the graph metrics. And then here I can change the information about the graph. So usually what I change here is the statistic data and the period. Yeah. So when you have a metrics in 1 minute, there might be like several metrics that is sent to CloudWatch, but we want to group them together inside of the period. And here, what it's saying that it is grouping all the data for every 5 minutes together, and it finds the average of the data, and then that is the data that is displayed here. Okay, so here at 13:25 UTC, and then 13:30, so it emits data every 5 minutes. I can change this, and I will make it to like 3 minutes every 1 minute, and then you can see that the graph becomes spikier. And instead of average, I am more interested in the maximum value of the CPU utilization in 1 minute. So I change this to maximum, and then get this data. Yeah. So these are the two important things, because usually when you monitor, you usually don't monitor the average. You usually monitor the worst case. So if you monitor latency, for example, you want to monitor something like P99 or P90, and this is like the 1% of the slowest request that you have. So you can change them here. And once you have selected the metrics that you want, I could select another one, this one, not sure what it is, but I could select multiple graph. Then they will change the color automatically with the same statistic and period. And then I could create a dashboard from this graph. So I click on the action on the top right, and I go add dashboard. I have an existing dashboard, but let's create a new one. Let's say call this test 02. Okay, and then the dashboard is basically okay, just save and continue. The dashboard is basically just an aggregation of money graphs, and also money graph, and also it could have logs and all other information in just one place. The idea of dashboard is you want to have a single place where you can glance and see whether your application is still healthy or not in just one single place, or maybe two places. Yeah. Here I'm going to add this as a graph. I could select whether it's line graph or stack or bar graph, but I think line makes more sense here. And I can customize the widget. Each widget is the graph in itself. And I add to the dashboard, and it's redirect me to this dashboard test 02 automatically. And since it's new, it doesn't have any other metrics beside this one. And it has only the graph of the two metrics that I chose. Okay. I save it for now. I could add other graph also. And instead of going to the metrics side, I can just click on add widget here. Choose which type of the information, which type of the graph I want to add. Here I use stack chart instead. And then I choose the metrics. And then I come back to the same page that I saw before. And I look at the container inside, the pod name, dimensions, and then I could add some of the graph with all the information. Okay. So this one, the metrics is about the amount of the network. Just create the widget and then this here. Yeah. So that is in a nutshell about the metrics and the network. In real life, usually the metrics that you are looking will be more complex than just, just adding the raw data itself. For example, if I go to the metrics here, and let me select, remove all of this, and then start again. And then I might want to have the combination of two metrics. For example, if I want to have, I have two metrics. Let's say I have an error. I want to have an error rate that happens inside of the application. Like this application might have like 100 requests in the last second, and then one of the requests fail. Then the error rate is 1%, like 1 out of 100. And I want to have this kind of error rate as a matrix inside of the dashboard. But I don't have I have only the metrics of the request and the error. So I need to combine both of them with the math expression. So we can do this also by selecting like multiple metrics. And then we can go to the graph metrics tab and then choose the math expression here. Here you can think of it as like very similar to the Excel, but it's for the graph itself. Like I have the sum here. This is a very straightforward one. It's basically just sum of the data of the metrics. And I can refer to the metrics that I want to sum by using the ID. M2, yes, right? The ID is here. This one is M1 and this one is M2. And here I have a new graph in blue, which is the sum of the data from the orange one and the green one. So this way, you could make a more complex matrix on the top of the basic one that you have already had by using the math expression that we have here. You can explore that what kind of function that you have here. Sum is what I use quite often. I don't use if quite often, but it can be useful in some cases. And standard deviations and also rate is sometimes very useful. And you can also do some of the conversion, but this is basically just basic math. Like for example, if I say byte to megabyte, if I click here, it will add a new matrix. And what it does is it's basically just divide everything by 1 million to convert byte into megabyte. And that's it. So I could just use see an example here and then copy this and then use it in the details here, update this one to change these values into megabyte. I think I made a mistake here. Yeah. And I removed this one because it's just for an example. Okay, so that's the idea of the math expression. So you want to combine multiple metrics together, plus negative on just some calculation on the top of it. This is the features for it. Okay, back to the slide. We have seen how to pick up metrics and create metrics and also put it in the dashboard. Do a quick recap. When you use the metrics, you have to select them based on the namespace and the dimension. We have the built-in and the custom one, the AWS namespace and the custom namespaces. Usually, if it is infrastructure type of metrics, you can use the AWS one. But if you want to have your own custom metric, then you will have to create your own custom namespace. The dimensions, which is basically when you talk about dimension, you can think of it as like a label of the metric itself. For example, you have like multiple EC2 instance, and you have an instance ID as the label. And let's say you have a website with 10 EC2 instance, and you have instance ID as a dimension. Then you can slice and dice the data based on that dimension. For example, I just might want to look at the data from the EC2 instance, just one ID, just the ID number 1. And then I can ignore and filter out the other 9s. So that is the idea of dimension. The dimension is what you have seen in when you go to all metrics. Let's start from the beginning. If we go to the all metrics, and then you can see this column. These columns are the dimension. If you go up to the level of the CloudWatch Insight here, you can see that there are different kind of dimension that you can use to slice and dice. You have the top level, which basically is just the cluster name, or you can go deeper. Like this one, it has instance ID and the node name. Okay. And then we talk a little bit about the math expression, which is useful for combine multiple metrics and makes a more complex one. We have built in a custom metrics I mentioned earlier, and there's also the features called Metrics Explorer, which allow you to filter and aggregate and visualize your metrics by text and resource properties. I haven't demoed this, so let me quickly show you. Back to the CloudWatch page, you can see that there is like the Explorer here. Okay, so previously what I show you is you look at the metrics from one hierarchy, from the namespace down to the dimension and go to the metrics. Another approach is you just want to look from, filter it based on, some condition. So there are some template. You can use Explorer for that, and there are some template there already. For example, I can use the template for Lambda by runtime. Okay. So here, Lambda by runtime is it will show all of the metrics, well, not all metrics, but important metrics for Lambdas. There are 4 of them: the duration in P90, the errors, the number of invocations, and the throttles. Okay, and then the metrics itself is split by the runtime. Here, the runtime could be like Node 12, Node.js 12 on Python, different version of Pythons. And this specified here in the below. There's a split by, and then you can say that I want to split it by runtime. If I don't care about runtime, I just care about the language level, then I can change this to switch to language, sorry. And then you get very similar things. So this is a different way for you to build the dashboard. You can grab a lot of metrics from an existing template, and then you can change the parameters here. You can use the split by, you can use the existing, adding the metrics from here. You can also use some of the filter here based on the text or the properties. For example, I don't care about Node.js. I just want to see the language that is from Python. So you can choose property Python. Yeah. And it will create all of the widgets that has only Python metrics. Yeah. And after I am happy with the graph that I have, I could add it to the dashboard. I could use the existing one and then add it to the dashboard. And then we will have a widget that is, I have to switch to a new interface here. Yeah. Here we are. So the top 2s are the one that I added before. And this one is the Explorer. It adds all of the duration errors from all of the Python Lambda. Okay. And in real world, the metrics should have been discussed during the design phase, even before you build the application. And the reason for that is it is usually good to know and have a talk between the dev and operation and plan it in advance. And also, the dev team has to plan to emit all the custom metrics because they have to put the code to send the metrics to CloudWatch themselves. They have to put the agent into the application, into the EC2 instance that the application live in. So it has to be discussed beforehand. When you were having the problem with the application, usually it comes at the worst time possible. Like this from my experience that I got woken up at 2 a.m. to support some operation issues. And at that time, I do not have a lot of time to think. Right? The first thing that I do is just go to the dashboard because it provides me an overview. And the dashboard, if it has already been well thought, it can tell me immediately that what went wrong, which EC2 instance caused the problem, which service caused the problem, and then I can start digging deeper. And also, the dashboard itself is useful, but it is also important to have the thing called operational playbook in your team. Basically, the playbook should say like, hey, if something happened, if this thing happened, what should you check? And what should you do? And how to respond to it, basically. Let's say you see that an EC2 instance has high CPU utilization. What can you do to mitigate this? Because at the time when there's a real production issue, the first thing that you want is to have the least impact as possible. You want to minimize the impact and you figure out the root cause later. But at that point, you want to make sure that your service can continue running. So if it's running out CPU, an option is I might need to restart the machines. I might need to roll back some of the chain that I made earlier. And all of this should be addressed in the operation playbook. So the person who is even inexperienced in the team should be able to follow the playbook and be able to mitigate the issue. Last but not least is the metrics are usually revised after all incidents. For example, like I recall that there were the issue where I look at the dashboard. I woke up for the operation issue. I look at the dashboard. I see some spike in latency. But everything in our service, other metrics looks okay. So after a while, then I realized that, oh, the problem is not actually my service, but it's another service that I have to call to get some data. And then after that, we have a talk in the team, and then we add a new metrics that is from the downstream service to make sure that next time when we wake up, we can know immediately that, oh, there's a problem with downstream service, and I didn't have to troubleshoot to figure out what is the issue. Okay, before we move on, any questions so far? Okay, then the next question, after you have already had a dashboard and know whether your application is healthy or not, is to get a notification, right? We don't want the user to tell us when something is wrong. We should be able to know almost immediately. And to do this, we need some alarms. And that is the features of our CloudWatch that is built in. Let's look into the dashboard. Let's look into the service. We have alarms here. And I choose all alarms, and it will show all alarms that I have created. There are quite a few of them because I was testing this, but what we want to see, there are 2 alarms for this application. And these 2 are for the DynamoDB. But let's create a new one to see how it works. So first, when you set up an alarm, you need to find which metrics that you want to monitor and set an alarm on. And this step is exactly the same as what we have gone through. I go to the namespace dimension, and I choose one of the metrics. And then it should appear up in the graph, and I just select this metric. Okay, this is the same. The only difference is I have to specify the condition when I want myself to be notified. In this case, it is CPU utilization. So I could say that if the CPU utilization is above the certain threshold, let's say 70%, I want to be notified. Okay. And I could have an additional configuration. For example, like sometimes the application might spike to have 70% CPU, and it after like a few minutes, then it just go back to like 50 or a normal values. So that's fine, and I don't want to be notified in that case. So I can change this value here. It is the data point to alarm. So I say that, hey, I want to make sure that I only got notified after there are 2 data points that is above 70s. And if I go back to the period, I'm getting the metric is by 5 minutes. So that means if the average value of CPU utilization is above 70s for 2 data points, which is 10 minutes in total, then I will get an alarm. Okay, and another one option is the missing data treatment. So for this CPU, it should not be missing, right? But for some case, like if you're monitoring error, there might be a period of time, several hours, that there is no error at all. Ideally, it should always be 0. So you can say here that if there's no data, there's no metrics about error, I could treat it as good, I can treat it as bad, or I could treat it as missing. I would just use missing here and go to the next one. The next one is, after the alarm has been triggered, what do you want CloudWatch to do? And the simplest thing to do is just basically notify me. Maybe send me an email on text me, and we can do that through the SNS. SNS is another AWS services that is for notification. And here I could use an existing one or could create a new one. Let's say I create a new one, and then I can enter my email address here. Okay. And then I just create a new topic here. There are other actions that I can also do besides just notifying myself. If you use EC2 instance and auto scaling, then you can specify the auto scaling option here. You can use some EC2 action. You can create a ticket. You can also trigger the system manager action. So these are the options that are available. Okay. And here we have everything, and we can create the alarm. I will remove filter, and then here's the new alarm. Now, when we look at it, it's basically like with the graph and also the red line here, specifying what is the threshold. The threshold that I use is like, it has to be greater than 70, but you can also add the threshold when it is under some value. For example, if your application is popular, and usually there are at least 100 requests per second, and suddenly it drops from 100 requests per second to 20, then you can set the threshold, like if it drops below 30, then notify me also. The drop in the request, it might implicitly means that there is a problem with the application. So for the request, if it drops, it drops more than it's supposed to be, so you can assume that some feature is broken. There might be a bug that the user cannot use it, and then it's good to set notification on that. Okay. I have shown you the static threshold, which is the line here. There is also another features that if I edit here, there's a features called anomaly detection. Right? And if I select the anomaly detection and I go back here, you will see that instead of the line, you have a band. So this uses some kind of algorithm to specify that what are the normal values of this data. And when the data is outside of the normal range, it can trigger an alarm for you. This is the anomaly detection. For CPU, this doesn't make sense because we know that the healthy ratio is probably about 70 or 60%. But for the case that, for example, like the number of requests that I told you earlier, it might be useful to have to use these features to specify the range. And when you get outside of the range, then you get notified. You can also specify the threshold, like if you make this threshold give a higher number, the threshold will be wider, the band will be wider, so you get paged less. There is less chance for you to get paged. But if you reduce the number, it becomes very tight, and then there is higher chance for you to get notified. Okay, so I'm not going to update this. Just here, I just want to show you that there is also the option for anomaly detection to have the band where it will notify you when it deviates from the normal value. Okay, so that is the notifications. Next is the log. So you have already known that there's something wrong with the application, but next step is you want to troubleshoot and you want to know what is going on inside of the application. So there are two features that you should know in CloudWatch to be able to troubleshoot. The first one is you can actually just go to the log group, find the log that you are interested in. Log group is a kind of an aggregated level of the log. So here, like I have the aggregation of pet site, and then when I click here, then I could go to see the log stream inside. Each log stream is actually divided by the computation unit inside. For example, if you have an EC2 instance, then the log stream will be coming from a different EC2 instance. Or if you use Lambda and you have a different execution context, then you have multiple log stream. And then you can click on the log stream, and then you can see the log, and then you can see what is happening inside of the application. Like I said before, this has to be talked with the development teams, to know that what kind of log that they will put inside, so we can make use out of it. If we move from here, there is you can see that there are quite a lot of logs, and in the practical world, this is not very useful because the filter is very limited. So the features that we usually use is the log insights. And you can think of log insight as the way to filter and aggregate, filter and transform the log. For example, I want to see what is going on with the log group of ECS/petlist adoption here. Okay, if I just run the default query, I will get all the logs sorted by timestamp from latest to the oldest one, only top 20, right? And then I can look here. And with the queries, I could filter more. For example, I could, here I select just the message, but each of the, there are multiple fields in each of the message. And if I click on the right-hand side, the field here, then I can see what are the fields available. And using this field, I could do the filter or, sort or do something with the field. And if you type this field in the editor, it will do the complete automatically. So I run the query here with an additional column of method, and it will show the method on the right-hand side. Yeah. Okay, so this CloudWatch log insight. Some other example, like I have a query here, this one. Similar, but I add an additional filter in the end to filter only the message that has the word brown. Yeah, and this is if you remember the website itself, it has the request in search, right? And the search can search by color. And here I want to see only the request that is related to the search that is brown. So I could use this filter, and then I will see only the logs that has the word brown in it. Okay, so I recommend, like, if you work with log a lot, go to look at the documentation of Log Insight. There are many queries that will make your life much easier when you have to dive into the logs and troubleshoot the application. And there are some pre-made queries. If you look on the side, on the right, there are some pre-made query which you can use as a starting point. Like for Lambda, if I want to see the latency by statistic, I could just use this one. Okay, now back to the next question in the slide. I want to know that if my service is working end-to-end or not. And there is a solution for that, which is called synthetic canaries. And the idea of synthetic canaries is you have an application that kind of run every interval. So in this case, I have set up the synthetic canaries to run every 5 minutes. And what it does is it basically visit the web page visit the website, and it basically click on some of the buttons and just verify that the website is still working properly. And if it doesn't, then I could create an alarm and trigger it. So here in the canaries, I have 2 canaries. One is for the API, for the page search, and another one is for the user interface. Let's look at this one. Okay, so this canary has 2 steps. First is go to the URL of the website, and second is perform an action like a customer could do. And the canaries is passing all the time. If it's failed, then you will see the red dot here. If you switch the tab to the screenshot, the canary itself has a built-in features to make the screenshot of what happened when you visit the website. So the first step here, we navigate to the URL and it's loading. And then after everything has been loaded, it takes a screenshot. And then it starts to perform some action, like clicking some buttons. And then after it has finished it takes another screenshot. Okay, so this one is very helpful if like when the test fail, then you can come to look here that which step it happens in the user interface. There are also logs which record every step that it's doing. So this also for this is also for troubleshooting when something fails. Okay. So there's the canaries. The one that I show you is the UI one where it actually interact with the website. Another method is to have it interact with the API, and that is the second one. And this one is pretty much the same as the other. But the difference is that I made some of them fail here randomly. So when it failed, we show the red dot here. Okay. Give me a minute. I have to plug my battery in. Yes. Okay. Battery back. So that is the synthetic part. Last but not least is the trace. This is just when your API is slow and you want to trace that what went wrong with the performance. It will show you the calls inside the service with the latency detail. So here you can find it inside of trace in the application monitoring and the trace. Okay. And in trace, in this page, the first thing you will see is filter by the time and also filter by multiple properties. Here, let's say I will use the URL as an example. And then I am interested in only a specific URL, and then I could select the one. Here I am interested in search. Let's say that the search is performing slower than usual. I could just come here, look at the URL, and just filter out only the trace that is related to search. And then I add the URL to the filter. Okay. Now I can scroll down and go to see the overall performance here. So I could see that this is rather slow because the P95 sometimes is very slow because the P95 is 3 seconds. I expect like most of them will be under the second here. And then I could go to look inside of the trace. So this represents each of the requests, and I could go to look at the one that is slow and the response time is slow and go to see that what is happening inside that call. So here I see one that is 3 seconds. I'm going to click into this one. The first thing when you go to a specific request is you will see that what is happening inside this call. So we have the client calling to the search API, and then it is inside of the ECS container, and then it called DynamoDB table. And then I can look down and I can see the breakdown of the times that it is using, like what is happening inside of the method, inside of the containers. Here we have the control search here. And then from here, I could see that most of the time is spending on the scanning the DynamoDB. So I know that it might be because there are a lot of load in this DynamoDB partition, or scanning is not the right option. I might need to redesign the DynamoDB table to make a query instead to make it faster. So this will show you like the data that is happening inside the call. I have another good example here. So if we switch to save it in the URL here, this one has more information. So we have the client, it called the pet adoptions, and somehow it ran the SQL, and it also called the pet search. And the overall, it is very slow. If we go down into the trace, we can see a lot of things happening. Like it first makes some SQL. I don't know what it does, but it doesn't slow down a lot. And then it in parallel make a call into another service. And here we'll see that it is calling the search. And each search is called, it has a different pet ID. So this one has pet ID 3, pet ID 5, and so on and so forth. And each of this call, even though it's called in parallel, there is some call that is slowest, and this makes the overall call become very slow. If we go down a little bit, we will see that there is a DynamoDB call. And then here, this is a trace information from DynamoDB that it takes some time from DynamoDB to process each of the scan and then return back. Yeah. So in a nutshell, trace is very useful when you have a performance issue and you want to dive deeper on what really happens inside the application so you can find the bottlenecks. This trace, actually, the data come from X-ray. So when you're using trace, then you have to set that up in the X-ray with X-ray SDK to emit all the data. But CloudWatch have this dashboard, so you can also look at the trace from CloudWatch itself. Okay, that's everything. Any questions? Okay, if not, I will hand
No
back
questions. Yeah, no questions from my side. But yeah, the presentation was fantastic.
Thank you.
Yes, thank you very much.
Thanks for attending, Tim. Okay, if there's nothing else, I would like to close with showing you the observability workshop. So this one. If you plan to work, the thing about CloudWatch is that if you don't have the data, it's very hard to play with it, right? And this workshop, it have like a setup that generate all the load, so you can play with CloudWatch, and it has details on each of the features that CloudWatch provided, and you can see that there are much more than I could cover in this demo. So give it a try if you want to have a hands-on and get your hand dirty and learn more about CloudWatch. Okay, I'm going to drop.
All right, Jemmy. Thank you. Appreciate your help today.
Thanks, Raj.
Yep.
Bye.
Thanks, everyone. Bye bye.